Hello and welcome, ladies and gentlemen. We are still in Packet 5. I apologize in advance for the marathon video that I'm sure this is going to turn into. We're looking at Activity 5.1, Perimeter and Area of Figures on a Coordinate Plane, and it is a very long section, very long activity. Okay, so this one is going to be a long video. I will have timestamps for each question that I do and when they are started in the video, so that say you're on 5.1 and maybe you're on question like 10 and you just want to get to question 10, I'll have that timestamped in below so that you can just click on that and get there as you need. But for now, we are going to just get going working on this, okay? So we have this problem 1. It says consider rectangle ABCD. So here's our rectangle right here on this coordinate plane, nice and drawn out for us. Part A says determine the perimeter of rectangle ABCD. If you'll remember that the perimeter of a shape is the distance around it, okay? If you think of it like a field, it would be the amount of fencing that you need around that field to fence it all the way in. Okay, so to determine the perimeter of this, I will need some side lengths. Luckily, we don't need to do distance formula because these lines are on grid lines. When our lines are on grid lines, if they're horizontal lines or they're vertical lines, we can just count those units. Okay, so our bottom, our base here, side AB is 1, 2, 3, 4, 5, 6 units long. We know that this is a rectangle, so I know that opposite sides have the same length. Okay, so that means that DC is also 6 in length, and then CB 1, 2, and similarly DA will be 2 as well. So the perimeter is going to be the sum, or if we add up all of those side lengths, is going to be the sum of all of those. So our perimeter is going to be 2 plus 2 plus 6 plus 6. You can have this in any order you want. Remember, addition doesn't matter what order this in. It could be 2 plus 6 plus 2 plus 6. It'll be the same every single time. So 6 plus 6 is 12, plus 2 is 14, plus 2 is 16. So our final answer there for our perimeter would in fact be 16. Okay, so now determining the area of this, if you watched the last video or if you remember from previous classes, the area of rectangles is equal to base times height. So for this one, we could look at our base AB and say that that is 6. So our area would be equal to 6 times our height, which is 2, which would be 12. So on this bottom part, part B, our area is 12 for that one. Okay, those ones not too bad. Hopefully some review for you. Nothing too crazy going on there. Okay, now we're going to look at question number 2. We have Horace and we have Bernice. Okay, I'll just read it for you. Horace says that he determined the area of rectangle ABCD by determining the product of CD and CB. So these are two sides. He used two sides, multiplied them together, got his product, or got his area. Okay, and then Bernice says that Horace is incorrect because he needs to use the base of the rectangle, and that is the base, or that is the side of AB, not CD. Horace responded by saying that side CD is one of the bases. Who's correct? Explain your reasoning. So really fast, just to kind of go back and explain what's going on. Okay, we're still looking at the same rectangle, ABCD. Horace got his answer by, or I believe it's Horace, yes, let me double check. Yes, Horace, okay. So Horace got his answer by multiplying the length of CD and CB, and that's how he got his area. Okay, and then Bernice says that he can't use CD as a base because AB is the base. Just like the basement is the bottom floor in the house, she's saying that this bottom line needs to be the value that we use to find our area. Okay, the one thing that Bernice doesn't realize, or I guess that Bernice doesn't care about or doesn't care to acknowledge, okay, is that the base of the rectangle, so if I had my rectangle, here's a quick sketch so I don't have to flip my paper over again. Rectangles, they have a base and a height. Because rectangles are the way that they are, the opposite sides are equivalent in length. So this base, the bottom line, is going to have the same length as the top line. So in this case, just like we had A, B, C, D, whether Horace used line AB, which was the bottom one, or CD, which was the top one, he will still get the same answer. So technically, while AB is the base in the sense that it is the bottom line, because they have equivalent values, it doesn't actually matter. So who's correct in this case? It would be Horace. And then explain your reasoning. It would just be because both opposite sides in rectangles, excuse me. So the reason he's correct is because opposite sides in rectangles have equal length, and because they have equal length, then it doesn't matter which line you use as long as you are using one base and one height. If you used a base and a base, then you could potentially run into some trouble, but as long as you have one base and one height, it doesn't matter which base you use. Okay, so Horace is correct there. Okay, so now we're looking at a different rectangle. We're looking at rectangle RSTU, and it's up in space here a little bit. We need to calculate the perimeter and area of rectangle RSTU. Okay, so to do that, I'm going to count some units first. This is how I like to do it. Okay, so for RS, it's 1, 2, 3, 4, 5, 6. Okay, it's 6. The base is 6. The top is also 6 because it's a rectangle, and then we have 3 and 3. But we need to be careful. So unlike our last problem we just added these up and it was our perimeter. Now we could do that, but we would unfortunately be incorrect in this case because we need to pay attention to how our axes are labeled. Okay, so this x-axis and the y-axis are both labeled the same. So this tick mark is 300 units. So that means that in 4 squares, 1, 2, 3, 4, I went up 300 units. So that means that 6 squares is not going to be 6 squares like it was on the last one. 6 squares is going to be something much different. So in order to find out what this 6 is equivalent to in the total number of units, I need to figure out what 1 square is equal to on this x-axis, what 1 square is equal to on this y-axis. Luckily they're the same, so we only need to do it one time. Okay, so 4 squares gives me 300, so that means that 2 squares gives me half of 300, which is 150. Okay, so now 2 squares gives me 150, which means that 1 square would give me half of 150, which would be 75. So that means that 1 square on this graph, on this coordinate plane, as it's laid out, is equal to 75 units. So this 6 here is 6 squares, but each square is 75 units. So I would need to do 6 times 75 to get the total length of this bottom side, which happens to be 450. Okay, and so same on the top, 450, and then 3 times 75 is 225, 225. So our actual lengths are here. Okay, these outside numbers are the number of squares on each side, but the numbers on the inside here are the actual lengths. So then the perimeter of this would be the sum, or if we added up all sides, so 450 plus 450 plus 225 plus 225, okay, all of that is equal to 1350, right? And so we said on the last one that our area is equal to base times height. Our base, and we just found out, like Horace said, that we can use either one of these because they are equivalent. Our base is going to be 450, our height is going to be 225, so that means that we have area is equal to 450 times 225. And just for those of you that might not know, that dot does mean multiplication. Just because it doesn't have the x there, it still does mean multiplication. The reason we stop using the x once we get into this type of math is because when we use, say we have slope-intercept form, y equals mx plus b, we use x a lot, and so to use that x as a time symbol gets a little bit confusing. So this dot does mean multiplication. So 450 times 225 equals 101,250 there, so that would in fact be our area for this one. Okay, so that is question 3. Question 4 says, how would doubling the height of the rectangle affect the area? Okay, so I'm going to grab a separate sheet of paper here that has some squares on it, a little bit of grid going on, so that I can redraw this rectangle for us. So I'm going to say 3, we said it was 3 squares tall, 1, 2, 3, 4, 5, 6 across, and then, so here is our rectangle, okay, that I'm just going to, so we said what would happen if we double the height? Yes, what would happen if we double the height of this rectangle? So, okay, remember, imagine we have our RSTU rectangle, and I want to double the height of this. So here's our base, here's our height. I want to double that. So in dotted lines, I'm just going to go down 3 more units on both sides and then connect them with a dotted line, okay? So our original area was this, and so now we're seeing what happens when we double the height, okay? So this is 3 units, and it's the height, and I also added 3 more units, so that's like I added 1 more height. So our original area, or formula for area, is base times height. So that means that our original rectangle, okay, its area is base times height, whatever that might be. In this last one, it was 450 times 225, could be something different, okay? So now our new rectangle, new being including this, including these dotted lines, okay? It's gonna be one base tall, or one base, but we need to multiply it by the total height, and the total height of this new rectangle is h plus h, right? So h plus h is the same as 2h. So our new rectangle has an area of our base times 2 height. Okay, so another way I can write this is base times 2 times height. And then with multiplication, we know that we can flip numbers around. It doesn't matter what order they're in, so I'd say it's equal to 2 times base times height, which another way I could write this is 2 times the quantity, base times height. So if we look at our original, we have base times height. If we look at our new rectangle, we did this, we wrote all this, and the reason we did that is because we can see it's 2 times base times height, which is the same as 2 times our original rectangle, or the original area. So this means that when we double our height, we double our area. We have 2 times our original area, whatever our original area was. Okay, so now back to our question. For how would doubling the height of the rectangle affect the area? It would double, okay? And the reason that is the same reason I just showed you, all right? It's just gonna be because when we double our height, we get a new area, and that new area is double our old one. So now, question 5 says, how would doubling the length of the base of the rectangle affect our area? So I'm just gonna do a similar thing. Okay, I'm gonna go 3, and then 2, 4, 6. Okay, so here's our rectangle again. I have a base and I have a height. And then I'm just going to, in dotted lines, go over 6 more. 2, 3, oh, whoops, 2, 4, 6, and then up 3, and then over 6, okay? So similar to the last one, here's our original rectangle. And now we're doubling our base, which means we have b plus b, in this case 6 plus 6, okay? So again, the area of our original, okay, our original rectangle had an area of base times height. If we multiplied this base times this height, that would give us this area. So now to find the area of the new one, we're gonna go over here. It's gonna be, so this time we have that the area of this whole thing is base plus base, or 2 base, right, because there's 2 of them, times our height, which hasn't changed. So 2 base, or 2b times h. So now we're just going to do some math magic, okay? I'm just going to separate this out with a symbol. So this 2 times b times h is 2 times b times h. And again, I can rewrite that to be 2 times the quantity, base times height, which we can see now, okay, our original was base times height. Our new one is 2 times base times height. And so similar to the last problem, this is the same as 2 times our original area. Okay, so doubling the height doubled our area, doubling the length also doubled our area. So then we can go ahead and write that down here. How would doubling the length of the base of the rectangle affect your area? It would double. Boom. Okay, so that was number 5. Now, on to the next part. Okay, number 6, we have Chantel. Chantel used another strategy to determine the perimeter and area of rectangle RSTU from the previous activity. She said, if I translate rectangle RSTU to have at least one point of image R prime, S prime, T prime, U prime, these little symbols, I'm just going to read them as primes, okay? On the origin, it is easier to calculate the perimeter and area of rectangle RSTU because one of the points will have coordinates 0, 0. So, question 6 says, how do you know a translation of rectangle RSTU will have the same area and perimeter as the pre-image RSTU? Explain your reasoning. So it's saying that, so remember translations are the same as slides, okay? And a slide is if you, okay, so if I have a shape, say I have a triangle right here, a translation would be like if I wanted to move this over 6, if I wanted to move it to the right 6, I would have the same exact triangle. Obviously, I'm just drawing these, so they're not perfect, but you can imagine that these are the same triangle. Okay, a translation would be sliding it over. I could slide it down. Okay, say I'd slide it down 2. There's another triangle. Okay, so translations are just like sliding a shape around. So how do you know a translation of rectangle RSTU will have the same area and perimeter as the pre-image? Explain your reasoning. So one thing about translations, about these slides, is that we're moving the shape, but we're not changing the size of the shape. So perimeter area is based on the amount of space inside of a shape, right? The amount of space inside this, and perimeter is based on side lengths. So if I don't change the size of the shape, I'm not changing the area or the perimeter. And then explain your reasoning. So translations, so we would say, how do we know? So we'd say translations don't affect size of shapes. They only affect position. Okay, so if we translate a shape, we don't change its size, we only change its position. Because we're only changing its position, that means that we are not changing its area or its perimeter, okay? So explain why Chantel's rationale is correct. So she said that it's easier if you have a point. So right here, she says it's easier if you have a point that's on 0, 0. So why is it correct? Okay, well, for this shape, all of our numbers are positive, which is nice. But if you have a shape, say, oh, whoops, this was the wrong one. Say our shape, okay, this one was nice because it was all of our numbers were positive that we were working with. If you can imagine this triangle being over here, or this rectangle being over here, we would have some negative numbers to work with. If it was in the third quadrant, they would be all negative. That'd be really gross. So moving a shape so that one of its points is on the origin and all of it is in quadrant 1 makes it nice because it'll have all positives. And then also, another thing that's nice about it is that we don't have to, sorry, I'm just going to bring this right back, is that we don't have to count from, so like this point right here is 225. So to find the length of this line, we don't have to do anything crazy from 675 to 225. I can just count from 0 and go up to whatever I need to go up to. In this case, it was 450, right? So I can just do that and not have to worry about it, okay? So that is why she's correct. I'm not going to write all that out, but that would be your answer for number 7. Okay, so number 8 now, translate rectangle RSTU so that point R is located at the origin. So now, okay, I'm going to take this and actually do what I was just talking about. So we want to move point R to the origin. Remember, our origin is at 0, 0. Okay, so I know that that's going to be my new place for R. Okay, we said that side RU is 3 units tall, or 3 squares tall. So I'm going to go up 3 squares, 1, 2, 3. That's going to be my new position for U. We said that RS was 6 squares long, so 1, 2, 3, 4, 5, 6. There's my new position for S. And then ST was 3 units tall, so I can go up 1, 2, 3, or 3 squares tall. And there's my new location for T. And I can connect all these, and I have my new rectangle right there. All right. So that was what 8 asked us to do. It says translate this rectangle. And then A says list the coordinates of rectangle RSTU, R prime, S prime, T prime, U prime. So I'm just going to go right here, and I'm going to list the coordinates of these. We said that we wanted our new R coordinate on the origin, so that it'll be on the origin, in fact. Okay, S prime is at 450, 0. T prime is at 450, 225, and then U is at 0, 225. Okay, if you want to double check those, you can rewind and then pause on the translation, that new rectangle I just made, and double check those. Otherwise, we are good to go. So B says determine the perimeter and area of RSTU. What do you notice? Okay, so if I were to calculate the perimeter of this, I would look at the side lengths, okay, and I would look at the height. In order to save some time, because I'm already at 18 minutes on this video and we still got a little ways to go, I'm just going to go ahead and say that what we noticed up here, we said on problem 6 that translations don't affect size of shapes, they only affect position, that we are indeed going to get the same area and perimeter that we calculated earlier. So earlier we got a perimeter of 1350. If we were to calculate the perimeter on our new rectangle, we would get a perimeter of 1350. And on our old rectangle, we got an area of 101,250. On our new rectangle, you would also get an area of 101,250. The only way that you wouldn't get these two numbers to match is if you messed up somehow on your translation. So maybe say on your translation, okay, if you went, instead of going 6 units, maybe you went 7 units. Instead of going 3 units, maybe you went 4 units. The only way that you would have that different from what you had originally is if you messed up your translation somehow, which hopefully you did not. So there you go. So now, okay, so now we're flipping this page over. We're looking at number 9 now. That was number 8. Okay, let me fix my papers a little bit. I accidentally threw them off the desk. Okay, so now we're considering this quadrilateral LMNO. Determine the perimeter and area of quadrilateral LMNO. Round your answer to the nearest hundredth if necessary. And actually what I'm going to do right now, I just hit the, excuse me, I just hit the 20-minute mark on this video. So what I'm going to do, I'm going to wrap it up right now. Wow, excuse me. Got a peanut or something in my throat from earlier while I was eating some trail mix. Anyway, I'm at 20 minutes on this video. I'm just going to wrap it up right now, and I will do a part 2 for 5.1 so that I don't have to upload a 50-minute long video. So I will catch you all on part 2. If you have questions, let me know. I will see you all soon.